types of arguments. There are many types of, let's say, strategies you can use to prove an idea. Amongst those is three very big, large types, okay? Type number one is deduction. And deduction we've been talking about for a lot now. Whenever I say, oh, this is logical, oh, this is whatever, I'm talking about deduction. And it goes always, there's an accepted rule, and then it's a general, and then it goes to a specific example. That's how it works. So something like, if you follow me on slide 5, all cats like milk. Pixie is a cat, therefore Pixie likes milk. This is a deductive argument. What we kind of do on daily basis, and it's kind of what we do when we do science most of the time, is something else. We will call it induction. And this goes from, accepting that all cats like milk, because you can always ask the question, well, how did you know? Right? How did you know that all cats are? Well, I watched this cat and the other one and the other one and the other one, and I did enough observations. And then I said, well, you know what? All those cats seem to have something in common. They all like milk. And so if there's Pixie, this cat that we haven't observed yet, Pixie likes milk as well. That's how induction goes. Deduction says, oh, we know that all cats like milk, and then this is one instance of cats, and this is how we know. Whereas induction is like, hey, hold up 1 second. How did we get access to all cats like milk exactly? We have not. And so what we need to do is, we need to observe individuals in the world, and then generalize a rule, which then we can apply to a future observation. Notice next to the Pixie likes milk, there's a small asterisk. It's most probably, we're not really sure about it. Abduction works in the same way, where you go and you infer the best possible explanation, which is also something we usually do when we're doing science. And so you go like, oh, the cats like milk, that's what we've observed, and Pixie's ball is, the milk is gone there. So most probably, the cat drank the milk. Now, did we see it? Do we have any logical, deductive reason to believe so? No. We just assumed. And it's the best possible explanation. Best, between quotations, I don't know what that means. You define what's best, right? We go back to that internal sort of justification business. And if you follow on slide 6, you can see that there's this division between the two kinds. Whereas induction and abduction, traditionally speaking, right, in the literature, people have assumed, okay, you know what? We know that these are not quite sure, not most probably 100%. It's the most probable case, right? It's just close enough. It's good enough. It's close enough. Deduction gives us 100% certified, sure knowledge. This is perfect. This is the best. I'm hoping that you've gathered by now that I don't personally believe this. But we're going to stay in the mainstream for now. So this is the real problem. So what we've done in that video, what's happening over there, is there's this flame that we've never observed before, and we've observed all other flames, and we've made an inductive claim that says, oh, this one burns as well, and it doesn't. And that's the problem we're trying to deal with. This is a classic problem in science, and we're going to talk more about the details of it and how it's going. Let me know, is there any other question, any concern, anything? Slide 7 is also what this presentation is not about. I've used the word induction on slide 6. I don't mean mathematical induction. If you don't know what that is, forget about it. If you know what that is, there's beef between Russell and Poincaré on this, and we might do a room on this in the future. Poincaré claims that this is, something magical, and he doesn't like mathematical induction really. He's not in favor of it. He finds the same problems that we were talking about. Whereas Russell says, oh, this is a deductive argument, but it's kind of hiding. In any event, we're not talking about that kind of induction. We're talking about induction, which is, again, you're observing instances in the world, and then those instances, what you do is you generalize a rule from them, from those observations. All right.